Okay, so far, you already know how to do problems where there's a sine and a cosine, and where either the sine or a cosine is by itself, and the other one is raised to a power. Okay? So if there's a sine or a cosine, and if the other one is raised to a power, it's just plain old u sub. Alright? And these are the ones that we have done before. So if I'm going to do u sub here, what's the u? Cosine 2x. It's whatever's raised to the power. Not just 2x, because the cosine to the third would still be there, and that would be weird. So we're going to take u equals cosine of 2x, which means du is negative 2 sine of 2x. And we're missing the negative 2, right? So we really have negative 1/2 integral u to the third. And then we take the antiderivative of u to the third, which is u to the fourth, over 4. So you get negative 1/8 cosine of 2x to the fourth plus c. You can write it as cosine to the fourth of 2x if you want. I like writing it outside just because in my mind it makes more sense, but you can write it the other way if you want. Okay, so one identity that's really, really important is, it's called the Pythagorean trig identity, and it's that sine squared of x plus cosine squared of x equals 1. Okay? Now, I will tell you that that gives you two more things. If that's the identity, that also tells you that cosine squared of x is 1 minus sine squared of x. And it also tells you that sine squared of x is 1 minus cosine squared of x. You need to know these. Okay? Now, when these identities are used is when you have odd powers of sine and cosines. For example, if I ask for the integral of cosine to the third of x, notice on that particular problem, I can't do u substitution because there's not a sign there. Make sense? Okay? Or a problem like this. Why can't I use u substitution on that one? Because it's not just a sine x, it's sine squared of x. Okay? So when one of the things are odd, okay, and when there's not just a plain old sine, this is when these identities are going to be used. Okay? And the rule is that you change, you leave one of the cosines or sines extra because you need it for u substitution, but then everything else you use this formula. Okay? I'm going to do these two problems in just a minute, but let me just explain what I just said. So like on this problem right here, I would separate it into cosine of x and then cosine squared of x, and then I would use the identity for cosine squared of x. So it's like you separate it and you leave one of them alone because that one is going to be used for u substitution eventually. Okay? And you would change cosine squared of x according to the identity. Okay? This one over here. So the part that's odd is the part that where you leave one of them and then change everything else. So the sine squared stays. You don't do anything with it. And then the cosine, you would have one cosine, and then you would have cosine to the fourth of x. And this you would change. And that's a weird thing to change because our identity says cosine squared of x. So cosine to the fourth of x would be cosine squared squared. So it's going to be 1 minus sine squared of x squared. Okay? So if one of them is odd, you'll leave one of them alone and change all the other even powers using the identity. Okay? And then I'll show you how all that works. So let's go back, and we're going to do that first one that I just showed you. Integral cosine to the third of x. Okay, so what I told you was leave one of the cosines alone, and then the other one's going to be cosine squared of x, and we're going to change the identity. So what would cosine squared of x become?
1 minus sine squared of x.
Okay? After you change it, then you're going to multiply. After you multiply, you got to think about each integral separately. Sometimes you can just find the integral. Sometimes you might have to use substitution. So for the first one, cosine of x, I know the answer there. What's the integral of cosine? Sine of x. Okay? For the second one, I'm going to have to use substitution on that one. Okay? So I'm going to be doing this separately over here, and u is going to be a sine of x. du is going to be a cosine. That's really great because everything is there. So really that's just the integral of u squared, which is sine of x to the third over 3. So I'm going to give you a similar problem, and I want you to try it first before I do anything with you. Okay, so here's how I separated it first before I've multiplied anything. Okay, so these two things multiply by the 1, so you have cosine x, sine squared x. And then those two things multiply by the sine squared of x, which makes cosine of x and then sine to the fourth of x, or sine x to the fourth. Now you just do u sub with each one. So once you use u sub, you have that, and then you have sine of x to the third over 3 minus sine of x to the fifth over 5. Okay, so this one looks a little different, but it is still the same. It just looks different, so it's a little bit more complicated because of the square root of x, or square root of cosine of x. So if it's the same, if I'm telling you it's the same, what part of it do you think you're going to change? So we're going to leave it as like a sine of x and then a sine of squared of x over the square root of cosine. And then we're going to change the sine of x to cosine squared of x minus 1. No, 1 minus, sorry. And then you're going to multiply like sine times both things and divide by square root of cosine. So you'll have sine of x over square root of cosine of x minus sine of x, and I'm going to skip a step right here just to save room. When I divide sine of x cosine squared of x divided by square root of cosine of x, I want to combine the cosine squared and the square root of cosine. So how can I do that? So subtract the powers, so 3 halves, cosine to the 3 halves. So, or you can put cosine of x in parentheses to the 3 halves. if it helps you to rewrite this right here as sine of x, cosine of x to the negative 1/2, that would also be a good thing. Because now it's exactly like the previous problem at the end. It's just that you're going to have a u to the negative 1/2 and a u to the 3/2. And you might have to deal with some negatives here because you use cosine this time.
Negative cosine and negative 1/2
Plus
plus
2 plus
Pythagorean identity, the sine squared x plus cosine squared equals 1. That's really, really important when you have odd powers. Well, when you have even powers, there's two other formulas that are really important. And I really tried really hard to try to figure out a way to do it without having to know these two formulas. If it's just sine squared of x or if it's just cosine squared of x with even powers, you can do these two problems without knowing this formula, but you'd have to use integration by parts. However, if it's a cosine like to the 4th of x or a sine to the 4th of x, you've got to use the formulas. So I decided, okay, we're just going to have to use the formulas, and that way you don't have to learn two different ways. Okay? So, here's your formulas. Do these look familiar?
Yep.
Are they double angle formulas?
Oh, yeah, yeah.
And these are when you have even powers. We have sine.
These are called power reducing formulas, not double angle formulas. But anyway, yes, and they're both cosine, and that's confusing, but just remember it. With sine squared, there's a minus on cosine. With cosine squared, there's a plus on cosine. They're just formulas to know. Like I said, I tried to figure out a way without having to make you know these, but I couldn't figure it out with like powers other than 2. When I say even powers, I'm saying like there's a cosine squared in there but not a sine to the 3rd or not a sine. Okay, so it can't have an even and an odd. We're talking about only even. Okay, if there's an even and an odd, we're doing the odd rules. Okay, this is only when there's an even. And the problem that we skipped on our worksheet, that number 13, we can do that with this, and I'll show you how to do that in just a little bit. Okay? All right, so we're going to start off with, what number are we on? Sine squared of 3x. Okay, so we have an even power. We don't have an odd power of anything. So we're going to change sine squared of 3x to that formula that I just showed you. Now, in the formula, it has a 2x there. Well, x is like our 3x. So we're going to be multiplying the 2 times the 3x. Okay? So our formula is going to be 1 minus, okay, it says cosine of 2x. 3x goes in the place of x. So it's cosine of 6x over 2. Question so far? Okay, after you change it, okay, if there's other things there, you're going to have to multiply through and do some things. But after that, you're going to separate it. You're going to make this 1/2 minus cosine of 6x over 2. After you change it, actually, it's not as hard as maybe even some of the others as long as you know how to change it. Okay? So the antiderivative of the 1/2 is 1/2 x. And what do I do to find the antiderivative of this cosine of 6x over 2? That's a u substitution, where u is 6x. Since cosine's not raised to a power, u is just going to be the 6x. So your du is 6. So if I times by the 1/6 and also take that 1/2 on the outside, this is negative 1/12. Integral of cosine of u. I'll come up back to the top here. So I have 1/2 x. Okay, the integral of cosine is sine. So minus 1/12 sine of u plus c. Okay, so let's do one similar to that problem on your worksheet that we skipped. Or I'm going to make it x cosine to the 4th of x. For the sake of time, we're going to take off this x. If it were cosine squared of x, you could do it easier. You would have to use tabular after you change it the first time. There would be a part where you use tabular if it's an x. I'm just going to leave it as cosine to the 4th of x, though, so that we can save time and so that I can show you how to change that when it's to the 4th. Okay, so here's me multiplying it out. Be sure that you square the bottom also, and then everything divides by that 4. So I simplified it to this, 1/4 plus 1/2 cosine 2x plus 1/4 cosine squared of 2x. I can do each of those separately except for the last one. So what we're going to have to do on the last one. We need to change it again. And since it's already a 2x, then we're going to make that a 4x when we put it in there. Oops, I forgot my cosine, I'm sorry. I'm going to write it on the next screen. Okay, the 1/4 multiplies by the 1/2. And then the 1/4 multiplies by the cosine 4x over 2.
Okay, I got a little lost.
So this is 1/4 x. Alright, think about, I'm not going to write it all out just to save time and room, but if you need to, it's fine. U is 2x. So du is 2. So I need a half to go with that other half. So this is a 4th. And then the antiderivative of cosine is sine. And then we have a 1/8 x. Okay, on this last part, u is 4x. So du is 4. So you need another 1/4. So 1 over 32. And then antiderivative of cosine is sine. And there you have it.